creepy opening again. My gosh, I got to work on those openings. Someone's got to come up with like a cool, like, man, you got to do this opening. I'm sure I'll screw it up. It can't be cool, so I can't be cool. You know what I can do, though? I can make Dunkin' Donuts commercials. And get paid millions by Dunkin' Donuts. Just made some fresh brew upstairs, baby. Woo! Dunkin' Donuts. My name's Mr. Krause. You can call me Mr. Cough Key. Wasn't even funny. Was not even funny. Let's do these real quick. All right. Graph a line. Okay, we got a y-intercept of -5. 1, 2, 3, 4, 5. Why am I doing this with you guys? You guys should be like geniuses at this, right? +2, so we're going to go up 2, over 1. Up. By the way, these are the answer keys. These are the answer videos. The answer keys should be in Google Classroom right now, at least for my students. Oh my goodness, what a terrible line. And there's the line y equals 2x minus 5. You should not be here unless you have done these on your own. I'm going to redo this one because I don't like this one, but it's okay. It's not too bad. We're going to take this point right here, which is the point 4, 7. And we'll take this point over here, which is the point 6, 3. Now, it doesn't matter which one we use, but we know that our slope is down 3 over 2. So I realize that now m is equal to -3 over 2. Now, I'm not going to be able to use that transformations trick because you'll notice that it's not hitting at a very pretty point. It's kind of an ugly point. So that ain't going to work. So we're going to have to revert to y minus y1 equals m times x minus x1. So that little transformation trick, actually, we could do it. I'm going to do it. But I'm going to do it on the next one. So let's do it on the next one. So what are we going to do? So we're going to do y minus 7 equals -3 over 2 x minus 4. So this is y minus 7 equals -3/2 x minus, oh wait, it's plus because we got a negative times a negative. Now when you multiply by 3/2, divide by the 2, multiply by the 3. So 4 divided by 2 is 2, 2 times 3 is 6. And then we're going to add the 7 over, so I get y equals -3/2 x plus 13. All right, now I'm going to do it the transformation ways by using this point. Now remember, normally it's at the origin. Let me do this in black. Normally it's at the origin, but we move to the right 4 and up 7. So normally, remember, our normal equation is y equals x. That is the parent function of a linear function. Of a linear line, a linear function, whatever. We're going to move it. So y equals, we're going to change the slope, so it's -3 over 2, right, because we already determined the slope. We move to the right 4, so that's x minus 4. Now I'm behind my head. I know I am. Big old bald head in the way. X minus 4. And then what did we do? We went up 7. Plus 7. Now, if I complete this, I get y equals -3/2 x. -3/2 times -4 is plus 6 plus 7, and we arrive at the same solution. So actually, you could do it that transformation way. I don't even know what I was thinking. I don't know. I think I'm a little cray-cray. Cray-cray. Okay, now I know I'm cray-cray. All right, so this one here, real quickly. Which one? So we got line L and we got line M. So line L has a rate of change or slope that's -4. Well, what does that mean? That means it's decreasing everywhere. Decreasing everywhere. And it's got the rate of change is huge. This is a really large rate of change. Whereas line M, I probably should have put line L. Line M has I'm going to put rate of change, rock, of 1/8. So it's very, very, very shallow, not steep, or it's kind of shallow. But it's increasing everywhere. Even though it's increasing, because it's increasing, but it's increasing very, very slowly. Line L had a y-intercept of -3, so this moved down 3. And this one has a y-intercept of 4, so this one moved up 4 units. The big thing about this is comparing the slopes. This is a very large rate of change. -4 is a really large rate of change. I mean, if you think about it, this rate of change on this line is only 2. You're going to double that. So -4 is going to be a line that looks something like down 4 over 1, down 4 over 1. So it's going to be really, okay, if you hit those points, it'll be really steep. Whereas 1/8, that's got a very shallow and small rate of change. What is the rate of change for a linear function? So what is the rate of change for a linear function? Remember, it is simply just the slope. So if I wanted, this should say f of x, something like that. I got to fix that. So if I wanted to know the average rate of change for this, I know the AROC, or the average rate of change of f of x. Everywhere is going to be -4. It's simply just the slope. Now, I want you to prove it to me, so it's not good enough just to do that. So what we're going to do is we're going to find f of 0, because these, remember, are your x values. So what we have to do is find the y value. So f of 0 is equal to -4 times 0 minus 3. So this is -3. So my first point is 0, -3. Now I'm going to do f of 2. So this is -4 times 2 minus 3. So that's -8 minus 3 is equal to -11. All right, so we have to do the average rate of change. So remember, average rate of change is simply just slope. So we're going to do slope, m. So that's y subtract on top. So let me highlight the y's for you. Oh, I didn't write my other point. My other point is 2 -11. So let's do this. Be careful with this, right? So we're going to do -11. Negatives are going to bite you in the keister every time. Minus, because they're right here, minus -3. That's really plus. That's really plus 3. Be very, 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 very careful with. And then 2 minus 0. I don't really use parentheses a lot when they're not negatives, but when they are negatives, you absolutely really should get in the habit of it. So -11 plus 3 is -8 over 2, which is -4. So all of that work to prove that the average rate of change of a linear function was just the slope. Okay, so just remember that the average rate of change is slope, but that's how you find it. Now, how would you find an average rate of change if I give you the table? Well, I want the x value from -2 to 3. So here's -2, and here's 3. So we're going to do the average rate of change, AROC. So we're going to subtract the y's. 9 minus -16. 9 minus -16. By the way, that's 25. All over 3 minus -2. I just screwed up. 3 minus -2. 3 minus -2. I hate that. Come on. 3 minus -2 is 5. So in this case, the average rate of change was 5. Okay. This is a little funky cold Medina right here, baby. Now, funky cold Medina, your parents might know about that. So here's what we're going to do on this one. It says, I said determine the number of minutes. So let's see. Time will be our independent variable, right? Because you can't change time. Well, time's always changing. You can't really affect time. So that's our x values, and these are our y values. So average rate of change, AROC, is going to be equal to, I'll do the top, 32,445 minus 32,331, all over. Now, we got to figure out how many minutes this is, right? Because I want to do the average rate of change. I want to know average rate of change per hour, but I think it'll be easier just to convert these to minutes. So let's see. From 1 o'clock or 1:23 to 2 o'clock is 37 minutes. And then from 2 o'clock to 3 o'clock is 60 minutes. And then from 3 o'clock to 3:17 is another 17 minutes. So let's see if I add those up. I get 97 plus, that's 114 minutes. Now, believe it or not, if you subtract the ones on top, you get 114 miles in 114 minutes. In other words, it's 1 mile per minute. Well, if I'm going 1 mile every minute, aren't I traveling at 60 miles per hour? And that's the answer to the question. Tricky question, tough question, tough question. Okay, so let's talk about these. Average rate of change. Now remember, average rate of change is just slope. So if I look at this problem, the slope's right there. So my slope here is 1. So the slope of f of x is 1. Here the average rate of change is, I got to pick 2 nice points. There's a nice point, and there's a nice point. So it's down 2 over 3. Let me get a better pen. So my average rate of change here is down 2 over 3, negative 2/3. That's less than 1. So far this has got the highest, and this is the next highest. Then I want the average rate of change from 0 to 3. So I got to do 0 and 3. By the way, I know I've done that a lot, but it's not always the first one and it's the last one. Sometimes it's just a random, I could have done 0 to 2. Okay? So what we'll do is we'll subtract the y's. So m equals 7 minus 1 all over 3 minus 0. So that's got an average rate of change of 2. That's the highest. So the question says, is rank them from greatest to highest. So the greatest is g of x. That's greater than f of x. And f of x is greater than h of x. All right, last problem. Wow, this is pretty simple. All right, let's look at this. Is it a function? Remember, if we're looking for a function, we're passing the vertical line test, so yes. Is it a one-to-one function? No, it fails the horizontal line test. So you got to remember, for one-to-one, we're looking for the horizontal line test. So the answer is no. Now, immediately, as soon as you tell me a function, a graph is not a one-to-one function, I know that the inverse then is not a function. Okay? It kind of links. Now, let's talk about domain. Obviously, we're going to forever and ever to the left, forever and ever to the right. Range. Okay, what's the lowest value? The lowest value, remember, range is the one time you're going to use y values, or the one of the 2 times. So my lowest y value is 1, and we're going all the way up to positive infinity. X-intercepts, there aren't any. So we do empty brackets. That stands for empty. That's our empty set. It's kind of like 2 ears with no brain in the middle, right? That's empty. Like an empty head. Okay. My y-intercept, it looks like it's going to be 7. Increasing. Where is this thing increasing? Well, isn't it increasing here? And it's decreasing here. What's it doing right here in the middle? Neither. It's doing neither. So don't include the middle number. Reminder. X values. It's so easy for increasing and decreasing because you're thinking up and down to think of the y values. We do not use the y values. So the key point for increasing and decreasing is going to be right here at 6. So from 6 to infinity, it's increasing. Remember, don't include the 6. From negative infinity up to 6, it's decreasing. All right. Now, you got to remember a couple things, children. This means negative. Less than 0 means negative. This means positive. This means below x-axis. This means above x-axis. And that's what we're looking for. So on this first one, we're looking for below the x-axis. Well, it's never below the x-axis, so I'm just going to do empty set. It never even equals the x-axis, so I'll do empty set there. Where is it positive? It's positive everywhere. So it's always above the x-axis, so that's negative infinity to positive infinity. And if that's behind my head, I'll move it up for you. Oops, I got to move it over. All right, we're almost done. Minimum value. Now again, min and max are when we use y values. So this is one of the times, one of the 2 times, range, min and max that use y values. All right, so the minimum is right here, 1. Listing out numbers, listing curly braces. What's the maximum value? Well, it's going up forever and ever and ever, so the maximum value is infinity. All right, so now we're going to do the equation of a absolute value. Remember, the most important piece is the vertex. We move to the right 6. So remember, that's a minus 6 because that's backwards. and we moved up 1, so that's a plus 1. Look at the slope, rate of change, up 1, over 1, up 1, over 1. So if I'm writing this graph, I'm going to put no number out front because it's really just a 1. It's positive because it's going up, so I don't have to put that. We moved to the right 6, so that's x minus 6, and we moved up 1. And that, kids, is the homework assignment. All right, bye. Don't forget, someone's got to come up with a cool opening for me.